How's it going? So last time we talked, we were discussing angles outside of circles, and how we did big arc minus small arc divided by 2, and it gave us the angle. We work with arc measures and talk about angles. Today what we're going to talk about is how long are the secants, how long are the tangents when we have these relationships. When we were inside of a circle, we had chords and radii, and we found out that we could turn those chords into triangles and use similar triangles to find out the lengths. For this, it's a little bit different. What we want to do is we want to start at the circle, or at the angle, and run to the circle, HI, figure out what that number is, multiply it by the entire length of the secant, HP. People are going to be tempted to do HI times IP, but that's not what we want to do. Okay, same thing down here. We go HO times the whole thing, HT. And we set both of those multiplication things equal to each other. So let's go down here and look at a different scenario. What if we had one tangent and one secant? Okay, we do the same thing with the secant that we just did above. We go OT times the whole thing, O to B. We set that equal to, and when we do the tangent, we go O to H, and we can't go a second spot, so we just multiply it again by O times H. And we set those two things equal to each other. The one that's not up here is two tangents. We talked about that at the end of the last lesson. If you have two tangents, they're just equal. So that makes that a little bit easier, hopefully. If you have two tangents, just know that they're the exact same length. Just set them equal to each other. So this is kind of hard to understand, so I want to do one example here together to kind of look at how to do this. Okay, in this problem we have EF is 10, so I'm going to write that on our diagram. EH is 8, put that here, and FG is 24. Now when I set this thing up, I'm going to start with this bottom secant because it has numbers, and numbers are easier for us to understand than when we throw in variables. So we take here to the circle EF, which is 10, and we multiply that by the entire secant from E all the way to G. That is 34. Some people are going to be really tempted to do 10 times 24, but this whole thing is 34. We did 10 plus 24 is 34. Equals, and now we're going to do the same thing on top. This will be a little bit more difficult because we have a variable. So we have 8 times, and there's a couple different mistakes that happen here with people. The way we got 34 down here is we did 10 plus 24. We want to do the same thing up here, 8 plus x. So times 8 plus x. Some people will just want to multiply by x. Some people will want to say that whole thing is 8x. They'll just throw them together. But we didn't say this whole thing was 1024. We added them to get 34. Same thing here. We're going to do 8 plus x. Notice how I put that in parentheses. We're going to have to distribute. So we get 340 equals distribute 64 plus 8x. Okay, we can drop 64 from both sides. We have 276 equals 8x. Then divide both sides by 8. X should be about 34.5. So that's an example where you have two secants. I want to throw one up here really quick where we could look at what happens if we have a secant and a tangent. So here's my secant, here is my tangent. I'll put that as x. I'll say this is 4 and this is 14. Okay, so this length is a tangent, this one is a secant. So we do 4 times, this whole thing is not 14, the whole thing is 18, equals x times, and when you have a tangent, you multiply by x again. So we have x squared equals 72, x would be equal to the square root of 72. So this is a different scenario as you'll see when you practice this tomorrow.